Now we're going to talk about conservation of momentum. The law of conservation of momentum states that the total momentum of all objects interacting with one another remains constant, regardless of the nature of the forces between the objects. So in other words, all the initial momentum should equal all the final momentum. So we take, in this case, this would be for two objects. We could have more than two, but this is for two objects. Mass 1 times velocity 1 initial plus mass 2 times velocity 2 initial equals mass 1 velocity 1 final plus mass 2 velocity 2 final. You'll also see this notation too. You'll have v prime as representing velocity final. So you'll see that in Giancoli. We'll use a combination. We'll use different ones just depending, but yeah, v prime is the same as v final. So you could have, over here, v1 prime would be v final, and v2 prime would be v2 final. When we talk about this, it's important to consider external versus internal forces. External forces are coming from outside the system, and this external force could change the momentum of the system. Internal forces, however, do not change the momentum of the system. That's from the interaction of the particles within a system interacting with each other. So an external force in golf would be, the golf club is exerting an external force on the golf ball, and it's going to change its momentum, and that should make sense. So, the golf ball, if that's a system, right, and this is influenced by a force, the momentum is going to change. But this is different, like with collision between two pool balls, right? The forces they exert on each other are internal. They do not change the momentum of the system. So this one, the rightward moving ball, 7 ball experiences a leftward force, and the 8 ball experiences a rightward force. They have equal and opposite magnitudes, and they would experience those. Where we also see this is an internal force in recoil. So, here's a shotgun, right? So if you shoot a shotgun, you have the shot going out this way. And so what's the equal and opposite reaction? The shotgun's going to want to go back this way. And it turns out that the recoil, it's an action-reaction pair, and it's all internal forces. And so the gun and the shot are both not moving beforehand. So for the conservation of momentum, right? If you start with 0 momentum, you have to finish with 0 momentum. The way that works out is the momentum, forward momentum of the projectile, and the backward momentum of the gun. If you added up those, they still end up being 0 at the end. So as the gas from the gunpowder expands, it pushes the projectile forward, the gun moves backwards, and we get that equal and opposite reaction. Okay, so let's explore that with an example. Let's say we have a 75-kilogram man sitting in the back of a canoe. The man and the canoe are at rest in the pond. The man begins to move forward in the canoe at 0.5 meters per second. We want to figure out what happens to the canoe. So let's go ahead and establish that the man is M1. Let's establish that the canoe is M2. The initial velocity of the man, well, the mass of the man is 75 kilograms. Initial velocity is 0. The boat, or the canoe rather, is 120 kilograms. It's also not moving, right? So we can write out the conservation of momentum. So you can do that here with me. M1 V1 initial plus M2 V2 initial equals M1 V1 final plus M2 V2 final, right? So the initial velocity here is 0, making this 0. The initial velocity of the canoe is also 0, making that 0. Afterwards, you have the 75 kilograms times V1 final plus, M2 V2 final. So this mass 2 is 120. And what we're trying to figure out is what is the final velocity of the canoe? V2 final, right? So we can place our numbers in there. We should end up getting negative 0.31 meters per second as the final velocity for mass, or for the canoe. And so And that should make sense. You know, this is less than the 0.5 of the man moving forward because there's more mass, right? This is 120 kilograms. So if you actually take this value, place it back in here and multiply and add these up, you're going to end up getting 0, because if you start with 0 momentum, you must also finish with 0 momentum. Okay, so I'm going to have you try this one. We have a projectile launcher that's shooting a projectile to the right, and we want to find out the recoil velocity of the projectile launcher. So yeah, go ahead and pause the clip, solve for the recoil velocity of the launcher using conservation of momentum, and then you can hit play when you're ready to check it. Okay, so we've got our values. You know, hopefully you remembered that you have to be with your units. You have to be consistent. So 0.209 kilograms, and we should be getting negative 14.63 meters per second as the recoil velocity of the launcher. All right, so let's try this one now. We have a 60 kilogram person jumping off a stationary raft, sitting in the water with a velocity 5 meters per second to the west. What is the final velocity of the boat? So if we draw this out, let's make M2 the man and then M1 the canoe. Here we go again with one of the most important things in this unit is your signs. You know, 5 meters per second to the west. So what that means is negative 5 meters per second, right? If you set up your signs positive X, negative X. Because if you just would have thrown in, you know, just positive 5, that means that the man is jumping out to the east, which is not happening. So you can go ahead and pause the clip, go ahead and finish this one up, and we'll figure out what the final velocity of the boat is. Okay, so you should have gotten positive 1.5 meters per second, which means that the boat would be going to the east, positive X, and then the man is going in the negative X with negative 5 here.